Hello everyone, this is Junaid here from Edureka and I welcome you all to this interesting session where we are going to see how to detect plant leaf diseases using CNN. So without any further ado, let me quickly walk you through today's agenda. We'll start this session by understanding the problem statement and the workflow that goes along with it. Moving ahead, I'll be walking you through the various tools, frameworks that we will be using to work with. And finally, I'll end this session by working on a hands-on demo and giving you some of the recommendations when you're trying to develop this project. Alright guys, before we begin, please do consider subscribing to our YouTube channel and hit the bell icon to stay updated on trending technologies. And also, if you're looking forward for a deep learning training tutorial using TensorFlow, please check out the link given in the description box below. Alright, so let us now come back to our project. So here we have almost 2 GB of images and we have multiple subfolders, right? Each of these folder represents a disease or the name of a disease that occurs in plants on their leaves. Okay, the agenda over here is to train all our images, okay, with respect to the classes, and then we are going to provide a new image, let's say somewhere from the Google or some the image that we have not worked on, and see whether if our model is capable of generating or if our model is capable of detecting whether a particular image belongs to that particular class of a disease. So before we get started, I would like to mention that it's very important for you to know how to work along with the pre-trained model and how to build your own CNN models. And if you're someone who has never worked with deep learning, the deep learning full course video will be provided in the description box below. All right, so now let's move ahead. All right guys, so now you might be wondering, right, what is the workflow of this project? Like any other machine learning projects, right, or any other deep learning projects, the steps over here are pretty straightforward and similar. First off, we are going to collect our data. I've already collected the data from Kaggle and uploaded that to my Dropbox. Okay, so all I need to do is use the Linux command wget and get my data set from there. Once I've got my image, I'm going to pre-process my image. As I'm going to use a pre-trained model here, I don't need to do much of work. Apart from that, we are going to build our own model. And finally, what we're going to do is, validate our outputs or validate our model. All right, guys, so let me now quickly move to my code editor. But before that, let me quickly walk you through various tools and frameworks that I'm going to work with. First off, the tool that I'm going to use to write my code is going to be Google Colab. Okay, the reason why I'm going to use Google Colab is because it gives me a fast GPU and it's pretty easier for me to work over that. Apart from that, couple of frameworks that I'm going to use is NumPy, Pandas, and Matplotlib, and some of the frameworks that are kind of centered towards deep learning, TensorFlow and Keras. All right, so let me now quickly take you to my code editor and let's start with our project over here. Okay, as this is a very huge data set, right? The data over here is almost of 2 GB. I've already imported my data, and as you can see here, we have two parts here. First off, we have test images is something that we have not touched upon, and we won't be using this for our training or validation. The other type we have is new plant disease folder. Okay, so if I try to open this, we have two more folders. One is for the train, and inside the train we'll have multiple folders that belong to different classes, or I can also say it as different diseases in a plant. So if you want to see how this image would look like, let me quickly open one of these. Let me open this up. So as you can see here, this is the image of a particular plant, right? So this is of tomato plant. Okay, as I can see over here, we have some white spots which makes it unique to this particular disease over here. All right guys, so this is all there is about the data set. So let me now quickly move to my code editor and let's start working towards our model. All right, so first off, let's import some libraries over here. If you're someone who wants this data set, you can refer to this code over here or this link over here. All right, so now what we're going to do is let's import some libraries. So import NumPy as NP, then we have import pandas as PD, then we'll also import matplotlib as PLT. Okay, so these are the few of the basic libraries. Apart from that, I'll also import OS. Okay, so this should be it. Let's now execute this. Fine. So as you can see over here, right, all our data has been separated over here for training and validation. We don't have to work much on it, right? So we'll directly move on to building our image data generator. So for that, we'll have import Keras. Then from keras.preprocessing.image, we are going to import image data generator. All right, we'll also import something like image to array, and then another one is load image. Okay, so If you're someone who is looking forward to see how many images we have on train and validation, what we can do here is, let's do some EDA, exploratory data analysis. Let's say we have os.listdir. Okay, and now I want to see how many classes we have, right? So let me copy this up, copy path, and add it over here. And now we just need to look into the length. So len, and this thing over here as well. All right, so as you can see here, we have 38 classes of images. That is 38 different leaf diseases we have. Okay, and so now what we'll do here, we'll just directly load our image to our data generator. So okay, so it's going to be train. This would be image data generator. Okay, and this takes a couple of parameters here. We'll give here a zoom range. We'll say 0.5. Okay, and then we'll have shear range. Again, this I'll get as 0.3. We obviously have to rescale our image. This is pretty important. 1/255. But over here, as we're going to use pre-trained model, it's important that we also add that function. Okay, we'll do that in a while, and then we can also do horizontal flip. Okay, and now what we'll do here is similarly for validation data generator. So it'll be val data gen, and this would be train data gen, right? So train data gen. So this will be image data generator. Everything here would remain the same. All we need to do is rescale this by 1/255. All right, this looks great. Now the other step that we have over here is to load our image or pass the path. So it will be train. It will be train data gen dot flow from directory. Okay, and now directory that I'm going to give, let's say directory. Let's come here. This is going to be train, right? So we'll just add this path over here. All right, and now we have to mention the target size. So target size will be, let's stick on to the 256 comma 256. Okay, and now we'll also give batch size, let's say 32. Okay, one more thing that we're supposed to add here is pre-processing function. So we'll add it over here, and over here we're going to pass a pre-processing function here, but we won't be adding this pre-processing function to our data generator over here. Or what we can do is, instead of rescaling it, we can just pass this through a pre-processing function, and pre-processing function will have all the information over here. Okay, so let me add this up over here. And now similarly, we'll just do this for validation dataset. So this will be val. Everything remains the same. Let me copy this up from here to here. So instead of train, this is going to be val. And the other thing that changes over here is the directory. It's going to be this directory. Okay, so we have successfully loaded our data. So now before we move ahead, let's add this pre-processing function, right? So to add the pre-processing function, all we need to do is from keras.applications. We can load any of the model. So as you can see here, we have DenseNet, we have Inception ResNet, we have MobileNet, we have VGG16, and many others. So what I'm going to do here is I'm going to use, let's say, VGG16, right? So import VGG19. And apart from this, we also have to have pre-processing input. Okay, and we can also use this decode prediction. Let's execute this now. And over here, in place of pre-processing function, we'll just pass pre-processing input here. If you're passing this, we can remove this rescale from here. And similarly, we'll pass a pre-processing input here. All right, so let's now execute this. Okay, so as you can see here, we have 38 classes, and we have 70,000 images that belong to 38 different classes. And similarly, for validation, we have 17,000 images that belong to 38 classes again. So if you're someone who's really curious about, what kind of images that are present here, it's pretty easy to figure out that image. So all you need to do is, let's say this is our image for the test image, and then we have label. This would give me train data, right? So train dot next. Now let me execute this up, and let's see what is this train image dot shape. Okay, so as you can see here, I've just taken 32 images. If I take more number of images, what happens is we'll run out of RAM. Okay, so what I'm going to do now is, let's try to plot this up. So def plot image. This will take image array and also label. Okay, so now we'll have a for loop for im, l in zip image array labels. So that is image and then label. So now all we need to do is plot the figure. So plot dot figure. Okay, give the figure size. Let's give 5 pixel comma 5 pixel. Apart from that, we have plt dot show. Okay, and let's execute this, and let's also pass some data here. So if I pass as it is, right, I'm gonna plot all the 30 data, right? I don't want that. So I just want first 5. So we'll give here as first 5 or first 3, and similarly we'll do it over here, first 3 data, and let's plot this up. Okay, it's not image array, it's gonna be this one over here, t image. All right, so reason why we didn't see the image over here is because we didn't plot it. So it will be plt dot im show, and all you need to do is image. So as you can see here, we have some kind of pre-processing done. This pre-processing is done by this particular function over here. Okay, so what does that mean is, so wherever this model was trained, it made use of this particular parameters. So what we can do here, just to see, some changes, let's see what happens if I divide this by 255. Try to normalize it this way. So as you can see here, the color changes up, right? So this is what happens. All right, so this is all there is about pre-processing our images, and the same thing goes for our validation data set. Okay, all right, so now that we are done with working with our data set, what we are going to do now is create a model, right? So let me give a title here, building our model. All right, so first off, we are going to import numpy, which I've already done. Then we need matplotlib, which we've already done with that. All right, so now we'll go for keras specific. So from keras dot layers, import dense layer and flatten. Okay, and then we also have to do from keras dot models, import functional API, right? So to get a functional API, we use model. Okay, we have already imported our pre-trained model. Okay, which let me quickly show you over here. All right, we have already imported this VGG16. Let me try doing this again here as well, just so that everything is there in place, right? So we have VGG19 here, and finally we just need to import keras, right? So import keras. All right, so let's now build a model. So first off, we'll create a base model. So base model, and what this model contains is VGG19, and here we're going to provide input shape. If you remember, the input shape that we gave was 255, right? Or 256. Yes, we have given 256, so we'll give the same here, 256 comma 256 comma 3. Okay, and then we'll also have include top is equal to false. And let's import this. This will take some time. All right, it took a second or so. And now what we are going to do is for layer in base model dot layers. Okay, I don't want to retrain my model, right? So that would take me a lot of time again. All I'm doing here is transferring the learning. So label dot trainable, this is equal to false. And let's execute this now. Okay, we have given here as label, right? It's going to be layer. All right, so now what we're going to do is using functional API, we are going to build a main model. But before that, we have to flatten this up. So we'll have X, this would be equal to flatten. But if you want to see what happens over here, no, we can just use base model.summary. So let's see that first. So as you can see here, we have 256, 256, 3. And finally, as we go down, we have max pool layer, right? We just need to have this layer as my input, and then there's the max pool layer. Okay, so now what we're going to do here is just have a flatten layer, and the input to the flatten layer will be base model dot output. Fine. And now we have the final one, X is equal to dense. The number of units over here will be equal to the number of classes that we have. And if you remember, right, number of classes we had were 38. All right, activation function, we're going to use softmax. And the input to this is going to be our X from here. All right, so now finally we'll create our model. So this would be our final model. Then we have just model is equal to functional API, that is model. I will pass the inputs here. So base model dot input, and then we have the X over here, and that should be it. So if you want to see the model dot summary, so you will see over here that we have around 12 lakhs trainable parameters, and these are the two layers that we have added extra. Okay, so now what we have done, let me give you a quick recap. First off, we imported our data. Our data is present in this particular part, Dropbox. And once we have imported our data, we try to pre-process our data using a built-in function, that is pre-processing input. And then we try to see how our data is, that is basically visualizing our data. And then finally, we created our model. Now, the only thing that is stopping us from moving ahead is to train a model. But before that, let's have some early stopping, right? So let me go here for text, early stopping and model checkpoint. Okay, to work with this, we'll be using callbacks from keras.callbacks, import model checkpoint and early stopping. Okay, first off, let's define early stopping. So early stopping, I'll give it as ES is equal to early stopping, where this has to monitor our validation. Okay, before this, let me quickly execute this here. So here ES would be equal to early stopping. Then we have to monitor validation accuracy. All right. The minimum change in delta that I need, let's say 0.01. Patience, let's add 3. Verbose, let's say 1. And mode is automatically auto, right? So we'll not worry about that. So this is about our early stopping. And now we'll do our model checkpoint. Model checkpoint is equal to, we have model checkpoint. Here we'll have to pass the file path, best model. Don't forget to put H5 extension. Similarly, we need to monitor validation accuracy, minimum delta, and verbose. So I'll just copy this from here. And we'll add one more parameter here, which says save the best, right? Save the best only, and we'll give it as true. Okay, so as you can see here, we have defined our model checkpoints. Now it's time to add this to an array, because when we try to train a model, it takes this as an array. So we'll say we have callback CB is equal to ES comma model checkpoint. All right, so now that we are done, we are going to pass here history. This would be is equal to model dot train generator. It's going to be fit generator, right? So fit generator over here. First off, we are going to pass a couple of data. That is, we need to have the training data. So let's see what name we have given. Okay, train and validation, right? So train and validation. So first off, we have to pass train. Okay. Apart from that, steps per epoch. Let's say this to be 16. Epochs that I'm going to have is going to be, let's say 50. We have early stopping, so if there are no changes, we can fix that up. Verbose would be 1. And then we have callbacks. Callbacks is going to be CB, that's an array. Then we have validation data. This will be val. And then we have validation steps. Again, this I'm going to give it as 16. So this should be it. Fine. And let's now try to execute this. But before that, let me add this in an order and execute this up here. Okay, so it looks like we have not compiled our model. So let us quickly get that done first. So let me add model.compile. Okay, and here we have optimizer. The one I'm using is Adam. Apart from that, the loss. Okay, so for the loss, what we are going to do is keras dot, let's say, categorical losses, categorical cross entropy. Okay, and finally metrics. Here we are going to pass accuracy. Let's execute this now. Okay, so as you can see here, our model has started training. Make sure you have your factory setting to be GPU. If it's not GPU, it would definitely take some time. If you try doing this now at this point, what's going to happen is we'll lose all our data here. and we may have to reload it again. So let's see how this would go first. Alright guys, over here I have tried to change my runtime type to GPU. So let's now see what this would happen. Okay. Usually what happens is the first epoch takes the maximum amount of time, and the successive epochs don't take as much time as the first one. So let's now wait for our model to get trained up. Alright guys, so as you can see, our model has been successfully trained. Although we had to do 50 epochs, our model got trained in 8 epochs. The accuracy is fine. I'm not that satisfied with the accuracy, but one good thing is, our model is not overfitting, as the gap between our accuracy and validation accuracy is not that high. And also the gap between the loss and the validation loss is very narrow, right? So yeah. So now what we'll do is we'll try to plot a model. So if you have h is equal to history, hi is dot keys, or if I just put history and then just add h dot keys, yeah, I'll get these 3 parameters. Now all I need to do is plot these parameters, right? So let me quickly get that done. So as you can see here, the loss, that is the validation accuracy, is, there's not much gap between them. And let's also look for the loss. So the loss should decrease, right? So the loss was initially high and it has decreased over here. All right, so now this is how our model has performed. Now let's try loading the best model, right? So load best model. So for this, from keras.models, import load model. And now here our model will be load model, and then pass the path, and the model is present somewhere over here. Copy the path for this, add a semicolon, and yes. So now we have the best model over here. Okay, so now let's try to evaluate our model. All right, so we have, let's say, accuracy is equal to model dot evaluate generator, or let's just put evaluate generator. Okay, usually we pass test data here, but for now let's just add validation data. Okay, validation, and I'll just need first one. All right, so to give you a good insight, I'll write a print here with a string. The accuracy of your model is, let's say, ACC times 100%, and let's run this up. All right, so as you can see, our model accuracy is around 75%, right? We can obviously increase this model accuracy. We can perform some hyperparameter tuning and increase the model accuracy, but let it be for now. Okay, so now what we're going to do, I have this particular test, right? What I want to do now with this is try to run this, all these images, like individually, and see whether it's able to create or whether it's able to predict this particular diseases correctly or not. Okay, so first off, what I'm going to do here is path, and here we're going to provide the path. All right, let's say we'll write this as a function, right? So def prediction, and here we provide the path. Now what happens in this path is, first off, we have to convert this or read this image. So it'll be img, this will be equal to image, which I've already got it, load image, right? So load image, and I'm going to pass here as path, then target size. Target size is going to be 256, comma 256. Okay, and once this is done, now we convert this into an array. So I is equal to image to array, and just pass here as image. Okay, and before we can pass this through a model, what we'll do is we have to pre-process our image. So let's say it's gonna be, yes, as you can see here, we have to pre-process, we have to use pre-process input for this. So we'll just pass this through a pre-processed input. I'll just pass the value I over here. First off, let's see what this would look like. Print IM. Now we have path, and let's randomly take any value here and add this within a semicolon and this thing over here. And let's call this function this way. Okay, so as you can see here, we are getting an array, right? And if you want to see the shape, so as you can see here, we are getting 256, 256, 3. Now, in order for this to work in a model, we are supposed to add one dimension here. So, which is pretty simple. So, for that, IM image, this would be equal to np.expand dimension. All right. Now pass the value, that is IM, and then axis, this would be 0. So now what we'll do is print IM.shape. And let's run this. So as you can see, now we have this thing over here. Okay, good. So what we'll do now is we'll pass this through our model. So pred is equal to model.predict this image. And let's see what this thing returns. Print predict. Let's run this. And let's also run this here. Okay, so we are getting this value. So we have to take the maximum value of this, right? So this would be np.argmax. np.argmax. These values over here tell me by what probability it belongs to that particular class, right? So now we have to see the highest probability, 0. So this was for, let's take one more image and let's add it over here. And let's see how well this thing works. So yeah, we have got this right. Okay, so if you want to understand what does this thing represents, right? So to get that, I need to do is, let's say test, or it's going to be train dot class indices. Okay, so as you can see here, we have 2, right? So 2 represents credit rust. So what we'll do now is, let's try to create a dictionary. We'll try to do this before this function. Okay, so if I run this, I get a dictionary wherein I have these values, right? So what I do, classes dot keys, right? And if I put this here, this will give me an array, right? So I'll make this as a list. Okay, and now at the same time, what I'm going to do here, list train dot class indices. Classes indices is a function which is present in the data generator dot values. All right, so now we'll try to zip this and put that in the form of a dictionary. So zip, and this would basically be a dictionary. And let's try to execute this. Yeah, we are getting what we wanted. And let's say this is as a reference. Okay, and this thing over here, what this thing predict would return is the class, right? So what I'll do is print f, this would be the image belongs to, now what we're going to do, we're going to open this bracket and we'll have this reference, right? And the key for this reference is the maximum argument. So let me add that up, pred. Okay, and let's now execute this. So as you can see, it belongs to apple cider, this thing. So we have got it right. Okay, the rust one. Let's say I want this. Let me add it over here. Meanwhile, let me delete this and let's run this now. So we have got it right, correct, right? Corner human rust 2. So this is what we have received over here. Let us give one more try, some random thing. Tomato yellow curl virus. So let me, if I copy this, I know that this is tomato yellow curl virus, but not the model, right? So let's see if it predicts right. Yes, the model has predicted this right. It has predicted as it belongs to the tomato yellow curl virus. So this is how you can work with this. And by any chance, if you are someone who is looking forward to plot this image, you can further do that by using plt.plot. Okay, and make sure you plot the image before pre-processing the image, because once you pre-process the image, you know, the image would be something that we won't be able to understand. It's something which is used by the pre-trained model because it was trained based on that. Alright guys, so now that we are done with the project, now you might be wondering what can you do further ahead with this project, right? So well, you can implement this with a GUI where you can use a 𝐾𝐤𝐚𝐻 or Python KV framework or Pygame framework, where you can make that as a small application, and just using the H5 file, right? You can just get the predictions, and you can make it as a very cool project for your final year projects or final semester projects. Alright guys, with this we come to the end of our session. I hope you enjoyed and learned something new. If you have any further queries, please do mention them in the comment box below. Until next time, goodbye and take care.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!